here. All of our organizers welcome you here. I know it seemed like it was in the middle of nowhere. You're not walking into some secret hidden alleyway that's going to lead you to the unknown. I mean, maybe, I don't know, but we'll find out. But this is a lovely space, and we are very excited to be here. Please be advised that this event is being very much recorded. I think it's very obvious. You probably saw some photographers as well walking in. By signing on to this event, you have basically signed your life away. No, I mean, you've basically released, given us permission to use your likeness and voice included in public materials related to this event. If you have any questions or concerns, please don't hesitate to talk to one of us. And by one of us, I mean these people on here are the amazing people that make events like this happen. There's a lot of us, and most of us are here, and our community really tries to embrace tech enthusiasts from all walks of life. Our group is made up of folks who are bootcamp grads, who are current students, all the way to people who have 10, 20, 30 years of experience. So welcome. Here are some more QR codes. So pull out your phone if you have not joined our Slack community already. Maybe most of you have, because I barely see any phones out. You can join we have a lot of different channels that are very lively, about 800 folks, I believe, on our Slack community so far. There are, we do a lot of social events as well. It's not just about talking about technical stuff. We like to party. I don't know if you all like to, but we do that a lot. So if you want to come hang out, you have to join our Slack community to find out what we do. Follow us on Instagram. So we have a very active Instagram that is really a fun time to follow, in my opinion. One of the things that we're doing these days is we're playing softball, and we're really enthusiastic about it, and the team's name is Sashimi. So if you want to see how we're doing, I mean, we're losing most of our games, don't get me wrong, but it's a fun time. So come follow us on Instagram. We do have a lot of like dev tech related stuff on there too. So yeah, follow us, please. We need those follows and likes. Follow us on LinkedIn. A lot of the content we post on there is a lot more professional than the stuff we post on Instagram. So if that's your cup of tea, please follow us on LinkedIn. Listen and subscribe to our podcast. I know we're almost done here with all the QR codes, but this one, this is relatively new. We've been doing this for a couple of months. The hosts have a lot of fun, and we are hoping the listeners have a lot of fun too. We are on Spotify and across all different podcast platforms. When we just talk about random stuff sometimes, but sometimes we talk about really cool stuff and interesting things, I think. So come give us a like and listen to the full episode. Don't cut out at 15 minutes. That's the analytics we saw. Yeah, we saw, but that's probably our fault. We'll try harder, but please listen to the entire episode. I don't care if you listen to us on 2 times, just listen to us. Thank you. Any first-timers here for a Tech Tank event? Hands up. Whoa! That's a lot of new people. Okay, yeah, round of applause. Thanks for coming out. Whatever your reason for coming out today, I hope this is not your first time. I hope this is not your last time, to coming out to our events. Okay, if you are interested in speaking, so today we are having a wonderful panel discussion of 4 panelists, but typically we usually have a speaker who teaches us about a cool concept. So if you have something that you are interested in, you want to talk about it, and you want to share it with the world, please scan this QR code and give us a little gist of what you want to talk about, and maybe you can be up here one day giving us a wonderful talk. Are you interested in hosting? So this is kind of, like this beautiful space here where we're blessed to be here. Like, it's not like one of us is a bajillionaire and we can just afford this. Like, we need companies to help us, sponsor us to be able to do this. And I'll introduce them shortly. But if you, I don't know, maybe you are affiliated, you're affiliated with someone in your company, and you think that you can host us and like have events like this in your company space, please, please, please come talk to one of us. Scan this QR code, or I don't know, we would love to talk to you, please. I think this is, oh no, not the last one, sorry. The second last QR code. There's way too many QR codes. I think we have to do something about this. But if you like what we do, if you liked my little spiel right now, I don't know, if you have benefited from anything that we do and you want to give back to the community to make sure that we can keep our mission alive with your support, please consider donating, or it's just techtankto.com/donate. Sometimes we hold fundraisers and stuff throughout the year to help us keep going. Believe it or not, we are a relatively young organization. I think we've been around for like a year and 3 months or something like that. So I don't know. Who knows where we'll be in 5 years, but we need your support to be able to do that. And is this the last slide, I think? So there is a hard closing time at 8:30 because this, as much as beautiful this space is, it took a lot of time to set up, which means it's going to take a lot of time to tear down. So I will have to get you to stop talking and move to, but that doesn't mean you can stop. You have to stop talking here. Like, you can continue your conversations, but we're going to head over to Hurricane Roadhouse, which I don't know exactly where the location is. It's a 5-minute walk, everybody, so you don't have to walk that far. And we're going to head on over there, maybe have another drink. It's a lovely day. Hopefully, everything you've heard today, you want to keep talking about it and get more engaged. So I think that's it. And I will hand over. I know I'm a little bit of a yapper, so you're probably tired of hearing my voice. So I'm going to give the floor to the wonderful folks who have sponsored us. It's 7 Shifts, who has generously given us their sponsorship to be able to run our event here today at Roof Garden. Can you give them a round of applause? And Raul.
Hello, everyone. On behalf of 7 Shifts, I'd like to welcome you all to this awesome event about unlocking AI. I'm super excited to be sponsoring this event. Part of what we do at 7 Shifts is unlock AI for our customers, so it's very relevant. I also love coming to these types of events. As a company, we love supporting these kinds of events. We've gotten a lot out of these types of communities, so we always like to give back. I've also personally got a lot out of communities like this. I would not have this job at 7 Shifts, which I have had for almost 9 years now, if not for events exactly like this one. So awesome to see all of you here. I would also like to thank Phil and Nat from Roof Garden for hosting us in this amazing space. This is my first time in this space, so I'll be honest, I would have said that even if it was a shitty space, but luckily it is an amazing space, so thanks to them. I won't take up too much of your time because I know you want to get to the panel, and I do too. I'm really excited for it, but I want to very briefly talk about 3 of my favorite things to talk about, which are 7 Shifts, AI, and 7 Shifts customers. So 7 Shifts is a company. We build a product for restaurants to basically help make their lives easier, help make restaurant managers and restaurant operators' life easier. We started out mostly as a simple scheduling app, helping restaurant owners manage their schedule, create their schedule, and share it. But we have grown a lot. We are now used by 1 in 8 restaurant workers in the United States. And we have expanded to support not just scheduling, but the entire life cycle of an employee at a restaurant. So that's hiring, training them, scheduling them, doing pay now, and retaining them. So if you want to learn more about 7 Shifts, please come find me after. Luke, who's on the panel, CTO of 7 Shifts. Martina's in the crowd. She's got a 7 Shifts shirt. Go talk to her. And there's other 7 Shifts folks here as well. When I started at 7 Shifts, there was 10 of us, but even then, we were very focused on creating a great user experience for our users. And so part of the hard part of using 7 Shifts that we identified early on was just getting started, because restaurant owners were always very busy, and they needed to go through the process of moving their schedule to 7 Shifts, and that took a lot of time. So to make that easier, we would get them to send us an Excel file, and literally our CEO would take that file, manually create the account, and then send them an email and be like, hey, your account is ready to go. So this did provide a great user experience, but pretty quickly we realized this was not going to scale. And so a younger, naiver me thought, I can totally automate this. So I tried to automate it, and I failed miserably. Yeah, so we shelved that project, and we actually had to stop doing manual account creations because it was just too much work for the number of customers we have. But we actually just shipped this feature like a month ago, and it works. And we built it relatively quickly, and it is powered by AI. So this problem that we could not solve, 5, 6 years ago, we can solve today, and we solved it relatively quickly using the power of AI. Okay, probably my favorite thing to talk about is our customers. We have a lot of great customers. One of them is who provided the excellent pizza today, Pizzeria Libretto. So big thanks to them, and yeah, please enjoy their amazing pizza. And as was mentioned, after the event, we will head down to Hurricanes Roadhouse, which is also a customer of 7 Shifts. So excited to check that out. And with that, I will hand it over to Riaz to introduce the panel. Thanks.
Awesome. Hi, everyone. My name is Riaz. I'm going to be the moderator for the panel, and I'm going to invite the panelists up now. Scoot over just a little bit. All right, can everyone see us? Great. All right, awesome. Well, again, thanks everyone for coming. My name is Riaz. I'm one of the admins of Tech Tank. And I'm going to let each of our panelists introduce themselves. So we'll start with Jay and go down the line.
Yeah, so I'm Jay Alamar. I work at a company here called Cohere, which was one of the pioneers of large language models. And I blog and create YouTube videos explaining how large language models work and how they can be used. Give it over to Rami.
My name is Rami. I've been working on research at the University of Toronto, pursuing my PhD. I'm specializing more towards AI for robotics. So the big goal of having the ChatGPT moment, but for robotics, except that this is not in the foreseeable future. So we try to make things better one step at a time. And that's it about me.
Awesome. I am Luke Galea, and today I'm the CTO of 7 Shifts. I lead a team of about 135 people in R&D, and we solve problems for restaurants, as Raul called out. So we don't explicitly use AI. We use whatever we need to solve the problem, and sometimes that's AI. I'll admit my intro is going to be a bit longer, but I'll just call out that throughout my career, I've spent my entire career using AI slightly after the label AI has moved on to the next thing. So this is probably the first time I've ever got to say I'm using AI rather than I'm using the thing that was called AI 10 years ago or 5 years ago. So in terms of my background, I'm sorry, I'm going to look at my. I started out in applied computer science. I was founding engineer at Blue Cat Networks. I loved it until we got successful, and I found I was spending all my time helping other people solve real problems. And so I decided I want to solve real problems for real people, moved into healthcare. And at that time, we were using the AI of that time was, expert systems, rules engines. And so we were using, early 2000s AI to prevent drug interactions from killing patients or what have you. So I will quickly blaze through some of this, but I was VP of R&D at Ashley Madison and a number of other dating sites. If you've seen any documentaries, there were some chatbots involved. Beyond that, so I've done fraud detection, propensity to purchase, so all of the business applications or customer applications of AI is where I've been at. So anyway, super excited to be here, and over to you.
Okay, hello everyone. Happy to be here. I'm Miles Harrison. I am an independent consultant and trainer at my own company, NLP from scratch. I just started doing my own thing coming up on a year ago now. And at NLP from scratch, I am providing training and consulting services in natural language processing, large language models, and generative AI, as is all the hype lately. I'm also a human being, although I have failed a lot of Turing tests.
All right, so as you can tell, we intentionally chose to have like a really diverse set of experiences on this panel, because a lot of times you'll have a panel of just like AI researchers, or maybe like one person from Google, one person from OpenAI, and it's kind of all a blend of the same kind of experience. We have people from industry, we have people from research, and I want to kind of get a little bit below the surface layer of like AI is some magic tool that just does things, right? So before we get into the meat of it, okay, I'll start with Jay as one of the educators, or maybe Miles, right? So give us like your definitions after the other of like AI and ML. If you're, let's say, maybe a lot of our audience might be programming React applications, et cetera, right? Outside of just making ChatGPT spit back like really intelligent code or Copilot, how do you define it?
So one way I advise people to think about it is that just the next level of software. So there were things that software was not able to do that now it's gotten much better at. So dealing with language, and we've all seen the applications of generating images, generating videos, understanding language, quote unquote, understanding language better than before. So it's not just comparing, matching keywords, or doing a grep, or doing email validation that a software developer sort of knows how to do. Now we can take things to the next level along these, and wherever there's rich data, so these specific domains of text, images, and video are clear ones. These models are able to do better with a lot less code. So you can have what used to be, if you wanted to do, let's say, speech recognition systems from 10 years ago, were maybe 500,000 lines of code. Now you can get away with 100 lines of PyTorch code, but with a large data set, and that software is built in a different way, and it has new and additional capabilities. That would be a sort of one way I would characterize it.
Yeah, so I'm just trying to remember the definitions of machine learning and AI from Wikipedia, which I forgot to memorize before I came here. So you'll see a lot of definitions that go something like this. It is the ability to get computers to engage in behaviors or perform tasks without explicitly being instructed to do things, right? So they're not deterministic. It's not traditional programming, right? There's logic, if this, then that, do this until that. But with machine learning, you have some sort of objective or patterns you're looking for, and you're using a lot of data to train what are essentially statistical models to either optimize for that objective or to find patterns in the information. And that is where there's that like meme where the person says, hey, can I borrow your homework? And the other person says, yeah, but don't make it look like you copied. So that's machine learning and statistics. But in all seriousness, we are really just, we now have the computational power to do these things and make product out of these types of models and algorithms that have existed for a long time because the computing power and the frameworks to do that are now there. An interesting factoid about this kind of thing that I like to remind people of is that large language models, neural networks are the cutting edge of machine learning. The mathematics that underpin how neural networks work have existed since the mid 1960s. It was only until we got the computing power that we have today that they actually became useful. Okay, and then artificial intelligence, I guess, is the broader category where you're trying to have systems that learn new behaviors from existing data and sort of be artificially intelligent. I'm using the definition in the definition, but that's as much as I'm going to say because I don't want to get into a big philosophical discussion at this point. So.
Okay, so now this is for anyone on the panel, right? So this stuff has been around forever. Even 10 years ago, 15 years ago, like if you had a Gmail account, it was using AI to figure out what was spam, what was not. Like probably some sort of, I guess it's a Bayesian algorithm is the kind of classification. Why are we all crazy about it now? So maybe one of you can kind of give us an explanation of the transformer paper, the attention is all you need. What happened? Why did we all go crazy for it?
I mean, I can definitely speak from like a business application perspective of why I'm more excited about it, but not the transformer. Do you want to start with the transformer stuff? Yeah. I mean, I will say that, like, from my perspective, old school, say, machine learning required so much data. Like, when I look at our customers, we only use old school machine learning with customers that have been open for a long time, with a lot of customers, with a lot of data, like 6 to 8 weeks minimum, ideally multiple locations. And the magic of modern LLMs and the like one-shot and zero-shot learning means that we're able to apply those same abilities to the mon-pos, the smaller. So I will say that from our perspective, it's almost like democratizing. It makes it so that you don't have to be Starbucks to have good, smart analytics intelligence around running your business. And that, I think, applies across all domains, right? Less data, more power with less data.
Okay, so let's talk about, most of the audience here is probably not like an AI researcher, like building AI. Like, we're probably, if you're in the field, we're building like general purpose web applications or backend APIs, et cetera. So like the development cycle generally is you get some requirements from like someone in product, right? You write some code in React or Node or Go, and you're like PR, merge, push to staging or QA, someone tests it, goes out live, right? Like, that's the cycle for 90% of the rest of programmers. Can someone give us an overview of like, that can't be the same model, obviously, if you're like building, the ChatGPT models or building like Claude or something. Like, how is it different? What's the life cycle of making this stuff real?
Of creating the model?
Yeah. Well, include an overview, like inference, I guess, would be after the model's created, right?
Yeah, so say you can, right now, these big foundation models, you can break down their creation into 3 steps. First one is called base training, and that is what takes the most amount of data and compute time, and that's when you train the model for a long time on a massive data set.
This is specific to an LLM model.
This is for LLMs specifically, yes, exactly. But this 1-2 punch of base model and then fine-tuned model is across, let's say, other modalities as well. But for language models specifically, yes, this training is on this task called language modeling. That's where they get their name. And that task is, okay, we have a lot of text that we got from the internet and from other places. We'll give the model 3 words and we'll ask it to predict the next one that follows from that. And if it will do it wrong in the beginning because it's initialized randomly, but we have learning algorithms that make it do better the next time by learning from this mistake. And then you run this for millions or billions of times, and then the model graduates and becomes a foundational model or a base model. And then the next step, and that's what, let's say, GPT-3, if anybody's tried it, it's a base model. A base model, when people started using it, they're like, okay, they might ask it a question, and the model might respond with another question, because in the training data that it's seen, there are lists of questions. But from the user experience that people interacted with the model, they're like, okay, maybe if I tell you a request, I want you to fulfill that request. If I tell you to write an article, give me the article back. Don't give me another request. And I give you a question, give me the answer to it. And so that's the second part of training, which is called SFT, or supervised or instruction tuning, where the model is trained to follow the instructions that it's given. And then the third, it can be called preference tuning, or it's sometimes called RLHF, reinforcement learning from human feedback, which is a way to change the behavior a little bit to make it more to the liking of people. Do you want it to be short? Do you want it to be long? Do you want the model to avoid talking about specific topics? That's the third stage, where sort of the model, and then you have a trained model, and then it's deployed, it's sent over to GPUs, and that's when the inference sort of comes in. You have new requests come in, the model is loaded up, it takes that input prompt, and it generates input and output response token by token, and all of those are streamed to the user in the end.
Just for our audience, if they're not so AI familiar, like define inference and let's define like tokens.
Yes, so text is broken down into word or parts of words, which in general is called tokens. And so a token can be a word or a part of word. And then now you're seeing language models extending to other modalities. And so a language model now, you can give it an image sometimes, or you can give it a video. And these other modalities are also, in a lot of scenarios, are being thrown into tokens themselves and being representations. So a token can be text, but it can also be tokens or information that sort of represent an image or audio or any of these, let's say, modalities or types of data that we give. Inference is, let's say, these are the two stages, I guess, of running an AI model. You train it, and then you run it to make predictions. So inference is just this step of making a prediction, which is one thing that makes a difference between the two is when you're training, you're doing in neural network language, you're doing a forward pass, and then you're doing a back prop pass to update the weights. But in inference, you're only doing one way, and you're doing the inference, and we can go deeper into those.
So I'm actually kind of curious. So this kind of makes sense because it's like for natural language processing or for what Cohere does, you're taking in a bunch of text and then you're predicting text. That's what ChatGPT is, kind of what we all know, right? But Rami, you work in robotics, right? So you don't get these like discrete tokens you can ingest and say, well, now here's a gizmo, some algorithm that tells the robot how to move its arm next or whatever. Like, how does that workflow differ for you in your field, or does it not? Is it pretty much the same?
So in robotics, actually, it's exactly a lot different. There are areas of robotics where you would want to work on understanding the language instruction coming from a human and then execute an action based on it. And in that, you can use something like multimodal large language models, in which, similar to how you would embed language and you would embed images, you can also embed actions into tokens. If you want to embed actions into tokens, actions could be something like a robotic arm going in like X and Y and Z position in the 3D space, and with a specific orientation as well. Obviously, this is an infinite space, so you would have to discretize that, and then you would embed these in tokens as well and treat it the same way as you would treat images or language. So that's definitely one area where LLMs or foundation models people have attempted to use in robotics. But in the more classical and still more popular use of robotics, you would use things like reinforcement learning, in which you would not necessarily try to tokenize any of your actions. So all your predictions are just variables that, assuming you're using deep learning, it's just inference or predictions coming from a neural network, which can obviously be continuous variables in that case.
Just a quick clarification of the word embed. In this context, it means translate into a numeric representation that the model sort of understands.
So like based on the kind of AI ML you're trying to do, right? Like I think in some cases it's kind of obvious how do you generate all the training data, right? So training data is like you give it a bunch of, for example, if you're doing most LLMs, you basically scrape the internet. So it's like all the words on Reddit and everywhere that you kind of say, here's human language, and then they get smarter about how to give you an answer. So robotics, I can imagine, how do you generate the training data? Or even other modalities that you guys have seen in the past. How do you generate the data, right? Because I feel like we've all become enamored with LLMs, but they have an easy way to generate large amounts of data to train the base model, which is go after the internet, right? Is this something that's just not really a problem in other fields, or it's a critical limiter in maybe other types of AI and ML?
Yeah, in robotics, this is actually one of the very limiting factors, the amount of data that's available. So some of the recent work, what they try to do is try to leverage all the robotics data that are available out there, where people in research labs all over the world had robots set up to do some tasks. So there was always a task requested from the robot, and then a human, an expert human, for example, controlling the robot to execute the task. So they would have access to the instructions, they would have access to the vision footage from the camera of the robot, and they would obviously have access to the actions that were conducted or performed by the human controlling the robot. So this is one example of how data collection works, but this is obviously very time consuming, and that's why they try to just leverage all the data that's available in the world. So this one direction where you have data that's already recorded and you try to train new models based on this data. Most of the time this is supervised learning, but we're not gonna get into that. Then the other type is like if you're trying to train a robot for a specific task. So you're trying to train a robot, a humanoid robot to walk, and avoid obstacles, or you're trying to train a robot to do something specific, then what you can do is you train it using trial and error. So the way that works, it's using reinforcement learning, where it would try to, let's just say in the worst case scenario, output random actions and then evaluate how bad these actions or good change the environment. And then it would get reward if it did something good, it would get negative reward if it did something bad, and then you will try to optimize your model to go in the direction of outputting the actions that result in better reward. So in that case, you probably wouldn't need any data to start, you just need a real robot, you need access to an environment, and you need to be okay with the risk that the robot can take actions that can lead. You cannot do that with an autonomous vehicle because it can run off a cliff just to get one reward, and you probably need to do that trillion times for the model to learn something. I think that's more than the people in the world. Yeah.
So, and you mentioned the word supervised. Maybe for us, like supervised versus unsupervised learning. Can you give us like a quick definition of that? Maybe
as an educator.
Yeah, sure. So here's the supervised versus unsupervised learning ELI 5. Okay. So in supervised learning, we have labeled data. So in machine learning, you are taking a set of information, which is your input data, or in machine learning parlance, features, and you are trying to learn underlying patterns in that to make predictions. In supervised learning, you have with each row in sort of your different descriptions of features, an associated data label. And then the task is to train the model to say, given these features, can you predict what the data label should be? And instead of using a realistic example from an industry domain or a use case or something, I'm going to actually use an example that is interesting and fun, which is if a young child is learning to identify animals, right? It learns about different features of the animals. Oh, this animal has 4 legs and is furry, so it's a kitty, right? And then the child sees a dog and says, oh, it's a kitty. And then the child's mother says, no, that's a dog. The dog goes bow wow. The kitty goes mew mew, right? So, or meow. So, teaching a machine learning model, you have different features, and then you're having these algorithms, and there are many different ones that you can choose from, see the underlying patterns. And what it's actually looking at is actually the variability across all the different features together to make predictions about some data label. Okay, so that's supervised learning. Unsupervised learning is where you take a whole bunch of students and then put them in a classroom and give them all tablets and then just go home. Unsupervised learning is different in that you do not have a data label for each entity. You have no data labels, you just have all the features. So I've got a whole bunch of animals. I don't know what's what. I don't know what's an amphibian, what's a mammal, what's a bird. I just know that some of them have wings and some don't. Some of them have 4 eyes and some have 2 and so forth, right? In unsupervised learning, one of the most common applications is clustering, and you're just giving the model all this data with no labels, and you're saying, suggest labels and groupings of the data to find out, sort of which things are similar, all right? Which, to explain in a very technical, kind of complicated, PhD level way, is like Sesame Street, where you say, one of these things is not like the other, one of these things is not the same. That is basically, at some level, of what clustering algorithms are doing. In the case of large language models and things like that, another really important type of unsupervised learning is looking for, you can do the same sort of thing. It's basically the same as clustering, where you are looking for topics of similar words and phrases and things like that in a very large body of unlabeled documents.
May I, as somebody with no academic background in AI, I'd love to test my really layman's understanding. I think of it as if I don't know the answer, then it has to be non-supervised learning. You have to already know the answer. Sorry, yeah, I inverted. Thank you. So if you don't know the answer, it has to be unsupervised learning. But if you already know the answer and you're like, I want to see if you get the answer right, that's supervised learning. Is that a good, like, you know, anyway, I'm trying to make it as unacademic as possible. Did I oversimplify it?
No, I like it. Supervised learning is teaching the algorithms by example.
By example.
Here are
yes.
lots of examples. Now I show you one you haven't seen before. What do you think it is, right? Whereas, you know, unsupervised learning is just, here's a whole bunch of stuff, figure it out,
Yeah.
right?
Yeah.
Okay, so like I see this as a couple of like different grades, right? Which is like if you don't have a lot of data, you're really kind of forced into sort of more unsupervised ways of learning, right? In some ways. I mean, and on top of it, like what is your input and output? If it's like LLMs, the nice thing is like there's like 5,000 words we kind of all use, right? And over, it's just patterns of the same things, and then you can spit out words. But robotics, it's much more complex. So maybe for you, I guess, Luke, or anyone who wants to kind of contribute to this. So we have like really smart people like Jay, like Rami, in sort of research labs or AI companies, and they've got all these ways of building this like smart black box, right? And then they say, hey, company, you can use this. Depending on the kind of AI model it is, like what capabilities for tuning and adaptation and integration into your company exist, right? Like what are the mechanisms once they're done that allow you to make it work in a practical way?
Yeah, awesome question. My answer is gonna be a little weird. First of all, like we will do everything we can to avoid using AI. And then if we're using AI, we'll do everything we can to avoid fine tuning it. Like from our perspective, you know, we are consumers of AI products that other people here are making for us. And then we're applying that to our specific customer space. So that also means that we try not to.
Can you explain why though? Because
Okay.
Yeah.
Okay, so part of the reason why is it's extravagantly expensive to do so. But it's also that like our job is not creating AI products. Like our lens is solving problems for restaurants. And if we allow ourselves to go down that path of just like exploring AI for all purposes, like that is us losing all track of our purpose for existing. Maybe we'd be a great AI company, but we would cease to be a restaurant technology company. There's a great article, which I imagine some folks have read. If you mention AI one more time, I will drop kick you. Is that a great article kind of talks about like if you aren't an AI company, you should not be training your own models. You should not be, and maybe that's an overly opinionated stance, but even with VC funding and not needing to be entirely profitable and all the rest of it, it still is not viable for a non-AI company to be training AI models. Again, maybe fine-tuning under some really unique cases, but I would much rather work with an AI vendor and have them do that work and give us something we can work with. And so to that point, we try and be model agnostic. So I don't know if anyone's encountered like Cloudflare's AI gateway, which effectively allows you to code against that and then monitor the performance of multiple different models behind the scenes. So I would say that like if you're in industry and you're applying it, you do not want to embed to the point where now you're no longer model agnostic. But I imagine if you're selling models, you don't want to hear that, right? You know, you want to provide a whole bunch of unique features that we code against, and then we can't just flip a switch and move to a new model because it's slightly cheaper or what have you. So I don't know if that answers your question. I'd love to hear if I'm thinking of it wrong.
I would generally agree. I'd hand it to you, Rami, but on the language model provider side, I guess, just as an answer. And I think I agree there in terms of we advise people to get the best tool for the job. And a lot of the times we have to sort of tell people that, you know, this use case, you're better off using regular expressions than using a massive generative model, for example. Or so definitely advising people to use the best, let's say, software practices, have unit tests, have reliable use cases. Some of the best AI capabilities from language models and other AI are not generative in nature, which is why I think Gen AI is a little bit unfortunate of a name. But things like search, embeddings, retrieval, these are a lot more, let's say, reliable than the generative side. And the generative side is a little bit more, let's say, it's a general problem-solving tool that can do a lot of things, but the reliability is different across different use cases. So we definitely advise for have tests, measure things, have benchmarks, have guardrails. But the things that you can do is prompt engineering. Fine tuning is the last tool in the box. Try to have if you can do something with a smaller model, do it rather than having the larger model. And Rami, I cut you off there, but you can.
Yeah, so I definitely echo what you said. I just wanted to say that yes, for AI, it's definitely much better to try to avoid fine-tuning or retraining your own AI models. However, there's a lot of room for customization that keeps your models mainly still agnostic. So a lot of in-context learning is usually good. And then it's usually when it comes to like cost cutting that you have something that would require a lot of inference, which costs a lot of money if you have very large context window or very large amount of data that or amount of text that you feed to your large language models in and out. Then at that point, it's usually wise to fine tune a smaller model. But when cost is not the problem or and you already have good quality output from a large model without any fine tuning, then it's usually not necessary. So a lot of people that I see ask about like, what kind of data do I need to collect before I can have this application running? Most of the time, you don't need to collect any data because large language models and foundation models are generally generalizing good enough that with minimal few shot examples, you'll be doing just fine in a few hours.
Yeah, so I have some thoughts. So basically in every organization, people at the C level are like small children with ADHD, right? So there is a lot
feel attacked. But go ahead, sorry.
There is a lot of shiny object syndrome happening, right? And there's also a lot of, when all you have is a Gen AI hammer, you want to turn everything and everyone into a Gen AI nail and hammer it in, right? And I gave a presentation for a client, and I have admittedly, Gen AI generated image, and it's a man, and he's standing in a suburb at the end of his street, and there's an F-16, fighter jet in the street, and he's looking at it, and his caption, his speech bubble says, "Well, this should help me get to the end of the street," right? And I really feel for people that are coming out of school or looking for work and trying to get into the AI space. And you see things on Reddit, people say things, they say things like, I'm trying to learn machine learning, and I'm trying to do a simple binary sentiment classification task, and I'm just trying to fine tune this 8 billion parameter language model, and my professional response to that sort of thing is, dude, step away from the laptop, slowly close it, right? No, I mean, it's not sexy to go into an organization, talk to people at the C-suite level, or talk to people at any level and say, yeah, you need to eat your vegetables. Maybe you don't need to do AI. Maybe you're not ready to do AI. And if you want to explore those things, there are use cases for them, but you're not a technology company. And I'm sorry, your CEO thinks you are, but you're not Meta. So you don't need to, fine tune your own model or train your own model from scratch. You'd be better off experimenting and doing POCs and building something with services that are already out there, right? And also, the vast majority, in my experience, across my whole career, of the work that you're doing, there's two things. The bread and butter of the business world and what is making things happen is very unglamorous, very important work, regular data analytics, visualization, data quality, data governance, very, very unsexy things to talk about that are not AI and machine learning. But any project of any type, whether it's software engineering or machine learning or machine learning engineering or whatever, you need to sit down at the beginning and say, what are we actually trying to do, right? What business problem are we trying to solve? Don't start and say, AI is the new hotness. I want to be AI. Say, what are we trying to solve for? And then these are the use cases and these are the things that these models can do. Does it make sense to use this thing here? Yes or no, right?
I would love to rebut the sentiment that all C-level executives are constantly trying, and not defensively. Like I'd actually really want to talk about it because I think.
Wait, because that's you.
That is, yeah, but no. I'm honestly not feeling defensive.
My spicy take.
I want to clarify because I think that investors and employees like using AI, right? Like from a CEO's or a CTO's perspective, I think that there is definitely a pressure to use AI from your staff and from your investors and what have you, but your customers do not want you using AI, right? Like all of the data is pretty clear that when you slap powered by AI, or like Raul talked about our AI schedule importer, like we don't say AI anywhere because it lowers customer trust. And so this kind of weird situation in which we're like, well, we want to use AI as much as we can to solve problems that make the business better without telling anyone we're using it. And I think that if there's other folks out there that are like falling on that side of being really open about it in product instead of letting the benefit speak for itself, then they're probably speaking to their investors or they're speaking to their.
So I want to look at that, but I want to look at it from the flip side, right? Because most of our audience here, they're developers or people that are trained to be developers, and that sort of most of the time general full stack variety, right? And for me at least, I can say, there's this notion of like, hey, am I going to lose my job? Is it going to be like GitHub Copilot's going to get so good I don't actually do my normal programming? Like when you go try to learn some stuff and you realize, like once you get beyond just hitting an AI API, and then you can change the temperature, right? Which is a sort of a metric you can throw into an AI for how creative you want it to be, right? For specifically a large language model or something like, or prompt engineering. Like, should I be going deeper than this? Because honestly, I had some conversations with some U of T PhDs who are studying AI, and they were just like, yeah, we also ourselves, like they're AI researchers who just take the Llama 2 model and customize it for their PhD. And Llama 2 is the model put out by Meta, Facebook, and they basically open source their model. And they're like, yeah, we're not building it from scratch. We're just taking and customizing it for our PhD. So I'm like, what is the low-hanging fruit or the appropriate level to which someone can be empowered by it, but they're not going to be maybe doing what you guys are doing, right, and going as deep? What's the missing link? And I have a feeling almost all of you have different answers to this question, so I'm really curious.
I would say for software engineers, this is emerging as a new type of job, the AI engineer, which is a little bit different from the ML engineer. So where it's not training a model, but in this conversation, there were a bunch of keywords that were not even mentioned in general discourse for software. Fine-tuning, in-context learning, few-shot learning. Like these are all new, even in let's say,
or
AI
RAG
and ML
or something
over the
like
last,
that.
exactly, in
Yeah.
RAG. So a lot of these need to sort of be a little bit, they're more common, and people need to have a little bit of a sense of what these are. And so, fine tuning is just training the model a little bit more on a specific data set to have a specific behavior coming out of it. Few shot and in context learning is not training the model, but having it through the prompt, giving it examples of the type of output that you want, which is a surprising capability that these models just started having the last 4 or 5 years beyond training models at a specific scale. Embeddings is another sort of important concept for people to have. So just knowing a little bit of these things, kind of like how everybody who's not a JavaScript developer needed to know what JSON is, for example, because that became just part of every software developer's lingo. There are a bunch of these ideas, and these are some of the main ones that come to my mind, at least.
So there's a lot when it comes to, for example, as Riaz mentioned, most people wouldn't try to train their LLMs from scratch, not because we don't want to, but mainly because we don't have the computational resources or the money to do it, or the time for what it's worth. But that's a good thing, because I'm pretty sure if we try to do it, we're not gonna beat Meta at it. So I think they're saving our time by putting a high barrier to it. For using large language models, generally speaking, I think there's definitely a lot of possibilities. There are a lot of uses that are sometimes obvious, sometimes not super obvious for people. And just by knowing how easy it is to build tools around your large language model. So I think a lot of people that I've spoken with are not aware, so they always try to, to follow up with what Jay says, like understanding context learning, future learning, all of these, but also understanding tooling and function calling. That's what I want to add to it. It opens way more limitless possibilities to what you can do with minimal amount of work. And it could be as easy as building something to automate, and I love automation, so I always mention automation, to automate something in your workflow at work. It could be automating something in your workflow at home. And it's usually not that hard, just by understanding the main concepts, and by trying to implement it. Most of the time, it just works, because LLMs have enough reasoning capabilities when it comes to simple tasks, and a lot of the tasks that humans are doing at work or at home are actually simple enough.
Awesome. I kind of think there's like maybe 3 ways of applying AI within your role. Like, one is writing code, actually like using it to write your code, not having your product use AI. And then having your product actually use AI is the other, and then having your business use AI to like automate workflows. I kind of chunk it into 3 buckets. But I did not include like building a foundational model from scratch or any of that stuff, because I think that that's the realm of like, my job is AI, not my job as a software developer. As a software developer, I'm not all that excited about like using AI to write code, just because we've tested it extensively and haven't seen this massive productivity increase. I think if a developer is like, I don't like Copilot, cool, awesome. Like, I think that we've seen bigger productivity increases just from language changes or framework changes or paradigm changes without getting into AI. So I definitely don't think anyone should feel like FOMO around that. I do think you need to learn how to apply models that other people have used to solve your problems, because like we've experienced entire classes of problems that we could not solve without, LLMs and RAG and what have you. And I honestly do not understand a lot of how the deep insides of this stuff works, and it has never stopped me from applying it, because there's people you can talk to. So I honestly think that you should like learn how to use it to solve your problems, and that's it, or go all in and live on the extremes.
How many people here use Copilot? Can you raise your hand? It's a good 40%.
What about if we include like another competitor, like the JetBrains AI assistant, like any sort of code assistant?
Cursor or...
Yeah.
Yeah, so I think I mostly am going to parrot a lot of what you said. There's a few different issues here, but I think these things are tools. You should use them to make the work that we do. I don't see, there's fear, and people are saying things like AI is going to take my job, and there's someone that I vehemently disagree with who is saying things like the profession of junior software engineer will be dead in 5 years. And it's like, sir, here's an iced tea, go sit down. Okay, like I'm not talking about AI. I'm looking at the development of technology over history, right? And it is 2024, I have no jetpack, we still have weather, and I am still waiting on...
Skynet's going to come for you first, man. Yeah.
I'm still waiting for the paperless office, right? No, but I think we're not ever going to see AI take jobs, but these are tools, and it's AI-assisted work, and it can make the work that we do easier and help us do it faster, and that's the idea. And also, I think for context, you can make arguments. There are definitely moral quandaries about job replacement by automation. There's a lot of quandaries that are outside the scope of this discussion about the ethics of the training data and copyright and so on. All that aside, just talking about work, there is a hilarious video on LinkedIn somewhere, and it is of accountants when they invented Excel, when Excel first came out. And basically, to be delicate, accountants just lost their minds, right? Because they said, you're destroying our livelihood, and you're taking our jobs, and it's like completely eliminating the role of a bookkeeper and so forth. And obviously, that's not true. but it is going to change work, right? So I agree that, artists, I can understand why if you're in a creative domain and you're not a coder, you have concerns, but also it's strange to say positive things about Adobe, but but companies have done things, and like now there are new, much faster, and quite frankly, really amazing workflows that people are developing by having these AI tools be integrated into product. And I think that that's something to embrace, but we still need to be cognizant of, the problems that are there.
So I love how like even I was thinking when we started this talk, like we're not going to just talk about LLMs. We're not going to, which is basically ChatGPT, but it's like we talked a little bit about robotics, and then like LLMs just suck all of the oxygen out of the room. We didn't talk about diffusion models to do image generation or anything. But I do want to turn to like a salacious topic, right? So alignment, bias, ethics, all of that kind of stuff, right? So alignment, and correct me if I'm wrong, but alignment is essentially how do we make sure that the AI doesn't kind of turn against us, like its interests are aligned with us, is the way I think of it, right? As it gets more and more powerful. This is obviously a thing that's really, really at people's, the forefront of their minds as people envision the AI models and the tooling around it getting so powerful. How do we make sure? So do you guys generally, not just at a general sense, see that as far less of a concern than people tend to be making it? Or are there mechanisms that we're implementing that will address it? Like, what are the ways in which it can kind of go awry? And maybe kind of dig a little bit into the technology and not just sort of what we think of at the surface level, right? I'm curious what your guys' thoughts are.
Okay, I can start with my thoughts. So I personally am not very concerned about like AI turning over, because AI is not that intelligent, not at all. If it can't add a flight to my calendar, I don't think it can turn over yet. But alignment generally, I think it's to a great extent important, but not to the way that it's hyped to be, mainly in my opinion, because AI is just a tool, just like any other tool. If it's not going to turn over, I think it's just a tool. So we try to build all these safety mechanisms in every like AI LLM, back to it, that we have. But these safety mechanisms are usually not in existing search engines. They are not in existing tools. So I wonder, why is that? Is it because people are always like scared of AI? Is it because of the competition that this company has the best safety mechanisms out there? I think it's still important, but I feel like it's taken way more weight than it should, because after all, it's about the people that use the tool. It's just a tool, and most other tools obviously it's a more powerful tool, so we need to obviously be more careful when doing it, but no matter how much we try to keep it safe, if it goes into the hands of a bad actor, they will find a way to break it anyways. So yes, ideally we would have something that is not easily manipulatable by a regular person, but after all, it's not that powerful in my opinion, and and it's basically not gonna get to the point, in my opinion, where it becomes powerful at least in the foreseeable future, to the level where I would be concerned. I'm more concerned about many other tools that already existed before AI.
Go ahead, Miles.
Oh, okay, I'll be quick. Sure I will. So there's people that are not even talking about alignment, but they're worried about, catastrophic, existential risk of AI systems. I'm, as you can probably tell from some of the things I've said, I'm a bit of a contrarian, but somebody else smarter than me, when I talked to them about it, they said, yeah, maybe that's something to think about, but I'm not worried about what AI is going to do. I'm worried about what people are going to do with AI, right? But at the same time, I think that some of the efforts around this concept of alignment, like what is Miles's definition of alignment, building the model to behave in the way that you think it should behave and tell you what you want to hear, but not tell certain users what you don't think they should hear, right? Because, you know, I'll try to color both sides of this debate here, all right? There should be, you know, checks and balances in place and safeguards, because abuse is a real thing. But also, there are models out there where they're very well aligned, and if you ask them a question about a certain town square and tanks, they will say, I don't know what you're talking about. I've never heard of that, and I can't answer that question. So I feel that some companies, and also to hilarious degrees, people have witnessed this, have kind of overcompensated and tried to get the models too aligned, and then it's like you're taking this tool and saying, hey, how dare you ask these questions and use this thing to do these things, right? If you go too far the other way, it's being irresponsible. And that is why I'm telling all of you, giving away this very important proprietary knowledge, that whenever there is a new LLM, my very first test for the alignment of the model is to ask it to tell me a Chuck Norris joke. And if it refuses to tell a Chuck Norris joke, the LLM is the same as a person at a party. I'm done talking to it. So.
Good test, good test.
I would say, yeah, I would put a distinction between two different things that people call AI. So one is the super intelligent AI, which we don't yet have line of sight into when it's going to come, if it's ever going to happen. Is it 5 years? Is it 50 years? And that is maybe more what the risks of things like Skynet and sort of other things. And it's a philosophical discussion in a way. And it's good. I think it's good that we have people who think about it. It's good for us to have science fiction that sort of speculate about the best ways to sort of think about that. So current day AI, there are the alignment of current existing AI is what I think about a little bit more, which is a lot of misuse, which is people asking a language model for, or people building, let's say, applications that diagnose diseases using a language model that is not, you know, specifically trained for this. Things like, you know, overly relying on these models for, you know, should you speak with them as a therapist or not? Maybe are you suggestible, for example, and the model can say things that shouldn't be said to somebody with a, you know, a case like yours. So like misuse, things like spam, like dead internet theory, like, you know, people will generate so much garbage text that it will be very hard to find anything on the internet. And so these are, let's say, a lot of present day alignment issues and, let's say, responsible AI that I think about a lot, and I think a lot more people sort of need to be thinking about them and building with products with AI with those risks in mind, I'd say.
I don't have a lot to say about this, but I have one of those Rabbit R1 devices that are, you know, everyone's talking about how bad they are, and they're terrible. I knew it would be bad. I just wanted to experience it. But one of the things I really like, the only thing it's good at, is holding it out and having the camera take a picture and then say, like, describe it in the voice of my favorite author. And that is useless. But an example of alignment is that I can't get it to do that if I show it anyone who isn't white. Like, it will be like, I'm sorry, I can't do that without being racist. And that's just like stock Rabbit R1. So like, one, that doesn't feel like they've actually advanced any ethics or alignment here. Like they basically have created what is this? It's a racist model that knows it's racist and isn't allowed to say it, but it's like, but I'm thinking it. So that's basically all that to say, I'm not so sure that the active alignment in that case actually was positive ethically. And I think the point is, like, how do you know it's positive? They obviously didn't know it was gonna do that. They just had a bunch of maybe good intentions. Anyway, don't
it's like the equivalent of saying, like, I'm not racist, but, right?
Like, not that there's anything wrong with that, but, and then, yeah. So all that to say, don't buy a rabbit, and yeah.
Awesome. All right, so we're gonna, go to the final question. So there's been so much attention on this field for so long, and you guys have been in this field before it was considered the popular thing. I mean, I guess it's been different terms over the years, right? 10 years ago, it was the big data, and everyone had like a Hadoop cluster, and they call that sort of your AI or machine learning or whatever. But oftentimes I find that when we focus really heavily on something, we actually miss more of it. Like the people that are in the know are kind of like, no, you're not paying attention over here. Like there's some really interesting developments, or we're all talking about this, but actually something else is going on, because people get like really narrow on what they think is the big thing, right? So we've all become enamored with LLMs, but is there something that you guys think like, hey, you should actually go learn about that, or this is interesting and no one's really talking about it?
I can go. I mean, everyone is talking about it, but like I think like neural radiance fields and Gaussian splats and like that world of kind of like AI for reality capture and augmented reality and computational photography. I think that space is super exciting. It's not generative yet, but I would love to see a multimodal model that can produce a neural radiance field, or somebody needs to define that for me. But anyway, super cool. Look into it. That's my answer.
Away from language models, every person in this room, maybe now, but definitely in 6 months or a year from now, will have more creative power in their hands to create images, videos, music, movie scripts than Walt Disney had, let's say 80 years ago or 70 years ago. It's very interesting for me to sort of imagine what humanity will be like when every individual sort of, can pay $3 of inference fees to 3 or 4 different companies and sort of be able to create an entire film. So imagining what that future will look like, that we're already seeing the potential of, is, I think, requires people to sort of experiment quite a bit and sort of find themselves. But it's going to be a wildly different creative landscape coming up soon.
Yeah, so this is something I haven't heard very many people talk about. I guess this is kind of a political statement, but it's also true. By nature of LLMs and training these new models that are very, very large, as we've discussed here, the pre-training phase requires a very, very large amount of infrastructure, which translates into money, which means that the only companies that can really afford to train a new model from scratch, pre-train one, have that kind of capital and size, right? That type of infrastructure. So mostly we're seeing, unfortunately, this sort of consolidation of power in very large organizations like Meta and Google and Microsoft and OpenAI, owned by Microsoft, right? And it's not really possible for someone at home to, on their laptop, make a new LLM. And I think a super interesting space that is still being developed is that of federated learning. So if people are familiar with like the folding at home and SETI at home type of projects, I think it will, at some point, someone will crack this very well. There are frameworks already out for this, and Flower Labs is doing some work around this, of having, being able to train transformer, other architecture models, large language models, in a distributed fashion. And then we're going to see, truly sort of open source models and actually like community or open development of models that isn't really possible today.
I guess for me, I'd say, 3 things. The first of which is still large language models. So multimodal large language models, I think it's a big thing. They're not there yet, but any work in the field of combining multimodalities, including audio, vision, including images and videos, as well as language, there's huge room for opportunities in that space, but it's not really that advanced yet. But when it becomes more advanced, there will be way more applications. The second field, I'd say, is also, in a way, large language models, but as we've already talked about it, I'd say an LLM that was available a year ago still has enough unleveraged capabilities in applications that are not yet realized. So there's a lot of room in growing LLMs, making them more powerful, depending on whatever metrics you use. But there's a lot of applications that are not there, that haven't even been using LLMs yet, and it will make a huge difference to use them. And then thirdly, which became more more obvious to a lot of people, is most of the classical machine learning algorithms are still there. They are much better. They are way more deterministic. They're still stochastic, but they're way more deterministic. They have much better explainability, and most of the applications that we see around us in the world are specific enough that they don't need the LLM hammer. So in that regard, there's a lot of the simple, over 10 years old algorithms that still have applications that are not yet realized.
Awesome. All right, so that is going to conclude our panel. So thank you very much to our panelists.